On the morning of October 23rd, residents of Acapulco, Mexico, were going about their daily lives as Tropical Storm Otis was expected to make landfall as a weak hurricane the next day. Little did they know that 12 hours later, a Category 5 hurricane would be barreling down on the city, defying all forecasts. In this video, we'll take a look at how this unfortunate scenario occurred and analyze the resulting devastation it caused. After meandering south of the Mexican coastline, a low pressure area formed into a tropical depression on October 22nd. Initial forecasts had the cyclone peaking as a weak tropical storm before harmlessly dissipating without even making landfall in accordance with weather models. This is because wind shear was expected to increase shortly, thus stopping further intensification despite the warm waters in that region of the Pacific. The depression strengthened into Tropical Storm Otis later that day, but remained weak. It wasn't until Tuesday that forecasters began considering significant strengthening. Microwave imagery from a satellite that morning revealed that Otis had managed to fight the seal and form a faux eye wall. At this point, the National Hurricane Center forecast Otis to make landfall as a Cat 1 hurricane, but even this more aggressive forecast would prove to be an underestimate. That afternoon, a U.S. Air Force reconnaissance aircraft flew into Otis to sample the storm in the hopes of providing a better estimate of its current intensity and to provide more data for weather models to assimilate. What they found was shocking. Firstly, the plane found flight level winds of 125 knots and estimated surface winds of 116 knots, indicating that Otis was already a powerful Category 4 hurricane. The plane also dropped two drop zones into the eye during its flight. The first one recorded a surface pressure of 972 millibars, and the second one recorded a pressure of 962 millibars, less than an hour and a half later. This corresponds to a deepening rate of about 7 millibars per hour, which is almost unheard of. The drop zones also indicated that the eye was rapidly drying out, which is a classic sign of rapid intensification. In these two charts from the drop zones, the red line corresponds to the temperature at varying heights in the atmosphere, and the green line corresponds to the dew point, which is essentially the amount of moisture in the atmosphere. Notice that the second drop zone recorded both warmer temperatures and lower dew points, meaning that the eye was simultaneously warming up and drying out as the hurricane continued its breakneck pace of intensification. At 7 p.m., the National Hurricane Center released a rare special advisory on Hurricane Otis, now forecasting Otis to make landfall as a Category 5 hurricane later that night. Such advisories are rarely issued, but with the record-breaking pace that Otis was intensifying at, they simply had no choice. 3 hours later, Hurricane Otis reached Category 5 intensity, packing sustained winds of 160 miles per hour. With a catastrophic impact inevitable, the NHC issued one of the most dire warnings ever, describing it as a, quote, nightmare scenario. Not only was a Cat 5 hurricane bearing down on the city of Acapulco, a densely populated tourist destination with over 1 million residents, but with how fast Otis had intensified, there was almost no time for any preparations. The hurricane then went on to make landfall in the middle of the night at its peak intensity of 165 miles per hour, with even stronger gusts approaching 200 miles per hour. This is essentially equivalent to an EF4 tornado, except instead of being a narrow funnel, the violent winds were everywhere surrounding the 15-mile wide eye. With it being the dead of night and almost all power and communications having been destroyed, it would not be until morning when news of the hurricane's impact would begin to emerge. Hurricane Otis had made history by being the first Category 5 landfall anywhere in the eastern Pacific. Before discussing the impacts, however, I want to try and give some explanation for why models underestimated Otis so drastically. As seen in this chart, just a day before landfall, no model forecasted Otis to become a hurricane, much less a Cat 5. This level of inaccuracy is almost unheard of with today's computer models. One possible factor was that the initial track forecast for Otis had it remaining offshore. This would have kept it away from a pocket of warm sea surface temperature near the coast, which Otis did end up tracking into and using to its fullest potential. Another factor was that models expected Otis to remain sealed for most of its life, but Otis was able to fend off the wind seal no problem. This satellite image shows what are known as seal spikes in the pattern of the clouds near the center of Otis. These are indicative of rapidly decreasing seal in the vicinity of a storm, which certainly aided Otis's intensification. Hurricane Otis was also located just south of a jet streak, which greatly increased its outflow and enabled the pressure to tank by providing an outflow channel to evacuate air from the center of the storm. Finally, Otis managed to maintain a very tight core of about 15 miles in diameter, which is a very favorable size for rapid intensification. Microwave satellite imagery shows the eye wall contracting and becoming extremely intense and well-defined just as it approached landfall. The core did weaken as the center of the storm moved over land, but by then it was too late. Hurricane Otis's winds produced catastrophic destruction along the Acapulco coastline and developed areas just east of the city. Countless luxury hotels and condominiums had their windows and even interior walls blown out, leaving hollow skeletons of the internal substructure. Such damage to high-rises is extremely rare, partly because Cat 5 landfalls on major cities are very rare in and of themselves. The airport also suffered major damage, making communication and recovery even more difficult. Torrential rainfall from the storm also caused numerous landslides and inland flooding, blocking critical roads. The Mexican government estimated that over 220,000 homes had been affected by the storm. Unfortunately, media coverage of this event has mostly ignored the poor areas of Acapulco, and full details of its impact will probably be slow to come out. Other smaller towns such as Coyoca de Benitez were also impacted severely, despite being further inland. These pictures show numerous houses in the town with partial to complete roof loss from Otis's strong winds. Most weather stations failed as a hurricane came ashore, but one anemometer located on Roqueta Island, just to the west of the highest winds, still managed to record sustained winds of 81 miles per hour and gusts up to 133 miles per hour. Much higher winds undoubtedly existed further east in the eye of the storm. A pressure of 957 millibars was also recorded on the island, but due to it being just outside the eye, the true minimum pressure of the hurricane was certainly much lower. Major hurricanes usually record significant storm surge, but the surge impacts from Otis were minor in comparison to the destruction brought about from wind and freshwater flooding. This is mostly because, despite its intensity, Otis was a very small and compact hurricane, which limited its ability to push ocean waters onto shore. In addition, the ocean waters are very deep just offshore of western Mexico. This is much different from the Gulf Coast or East Coast of the United States, where there's usually a large continental shelf that enhances storm surge. One feature of the winds in a hurricane is that they are not actually strongest at the surface. The winds peak at about 1,000 feet in the air, where they are around 30% faster than at the surface. Tragically, much of the urban sprawl in the surrounding mountains is at that height above sea level. The jagged terrain of the landscape would only further enhance the winds due to downsloping. Aerial footage shows the widespread damage and deforestation brought about by these phenomenal winds. This map shows how different areas of Acapulco and the surrounding metropolitan area experience varying levels of damage, with orange areas corresponding to minor damage and red areas corresponding to major damage. Notice that almost all of the worst hit areas are away from the coast, which is where one usually sees the worst impact from tropical cyclones, and instead up in the mountains. This is unfortunately in line with what is to be expected with strong hurricanes hitting mountainous regions. Officially, the death toll stands at 48, but sadly the true number of victims is likely much higher. NPR correspondent Ador Peralta reported that rescue crews had recovered 50 bodies in just one day from the ocean, and more bodies would likely be discovered for weeks. The hurricane also caused immense economic damage. Enki Research estimated that Otis caused at least $15 billion of damage, making it over twice as costly as Mexico's former, most expensive weather disaster, Hurricane Wilma. Hurricane Otis serves as a grim reminder that despite modern computer models and forecasting techniques, weather can still catch even the most knowledgeable experts off guard. Even though forecasting accuracy is constantly improving, at the end of the day weather is inherently unpredictable, and there is no substitute for general preparedness and weather awareness. As the death toll continues to rise and the true scale of the long-term impacts becomes clear, we can only hope that enough humanitarian aid reaches those affected by Hurricane Otis in Acapulco and surrounding towns, and that international awareness of the situation will grow.